Okay, everybody, welcome to this video. In this video now, we're finally going to go through and walk through the steps to configure a scripted build for our AWS AppStream images. As part of this video, though, we're going to step through a couple of things. We're going to talk about scripted build practices. We're going to talk about the Windows environment management and the application management principles, and how we go about managing things like user settings, application installations, that sort of stuff. And then finally, we're going to run the image build script to see it in action and to get a feel for how it runs and what it actually does perform and what it automates and things that it can't automate. And then finally, I'll share the script with you as well, so you can use that in your own demo environments and hopefully start to use this in real life. So, moving on to our scripted build. The first and foremost reason that we script the build is to ensure you have confidence in your image. When people come to you with complaints about the image not running properly, or there's a problem with it, or you're not sure that something isn't working properly, if you've scripted the image and you have a process that is sound around that script, you can have confidence in the fact that nothing should have changed in that image since it was last deployed. It also means that in that scenario, though, you've got a consistent, repeatable image, so if there's a problem with it, you could roll back to the previous version, or simply deploy a new version from your existing script and try and see if you have the same problems or issues on that image instead. If the image goes away, then you could safely say that there was something wrong with that environment, that machine it was running on, something like that. But the primary reason is really to script the build, give you that confidence for the image and the process that's there, and that it's sound and that the image is protected, so that it's a consistent and it's a repeatable image at all times. So that the image is the same for all environments. It doesn't matter if it's a dev environment or a test environment, or you've got 10 test environments, or your production environment, the image can be classed as or confirmed as absolutely identical. Scripting the build will mean that you save time, whether it's deployment of the image itself, whether it's in the testing of the image and you're updating applications and those sort of things, or whether it's just with the troubleshooting of the image itself. You can then also be sure that if you've scripted your build, you're going to prevent production image config deviation. Now, what do we mean by that? Effectively, it's kind of similar to where you have confidence in the image. You can be certain that nobody's logged into your image. They've randomly installed something, shut it down, and then redeployed it. So that way you can always be certain that your production image is stable, is sound, and hasn't deviated away from how or when it was built. And if it does, you simply redeploy it with your script, and it's back to where it was. Scripting your image will eventually mean that your image is turned into code, or as you may have heard in the world of cloud already, we're talking about things like infrastructure as code, which simply then means we can take our scripts and we can start versioning, controlling them. So we could have the last version is 1.1, and that was an installation of Office 365. 1.2 is an installation of Office 365 and macro is added to that, macros for Excel. We have problems with that, the testing failures on a few things, we can simply roll back to the previous version, redeploy that, and then suddenly we're back where we were. We've wasted zero time or very little time in redeploying the old image, and we could take it from there and troubleshoot the next version on the side before we impact production. We can reduce but not eliminate the burden of image management. Now, in some instances, you may find that you need to have separate multiple images in AWS AppStream because of conflicts or application versions or Internet Explorer versions or security or whatever that might be. So at least in those instances, because you have scripted the build, you have reduced the time it takes to manage and build those images, but unfortunately you won't have eliminated some of the burden of the image management. And then also that comes to the reduction of human error. You're not going to be able to eliminate the human error in these sort of things, but we'll certainly be able to reduce it because you're using a script that is again, repeatable process and it's consistent. So finally now, if we move on to application environment management principles, the first couple of things that I want to talk about are things like the Windows profiles. So if you think about the Windows profile history, you have a single Windows device with a single user that logs into that. It's an old Windows laptop and they log in and they install something. Those settings stay with that user and they have to manually configure it and change their settings and move their toolbars around and all that sort of stuff. But at any point, if that laptop fails or if there's an update or something that resets that information, they lose it and they have to do it again. So normally that's not a problem for a user on one machine. They lose their laptop. They just know that they have to go through and set all that up again. Along came a little bit later in Windows World, along came things called roaming profiles. We could save the user's settings remotely onto a share or onto a NAS or an NFS machine, and that saved the day, really. However, roaming profiles were a bit slow, they were a bit clunky, they quickly got out of control because users had saved something silly to their desktop and it'd be hundreds of gigs of CD information or ISOs or something like that, and the user's logon would take 4 hours. So, in that instance, roaming profiles were good so long as they were managed carefully. And I think I didn't really truly learn about Windows profiles and non-persistent desktops and mandatory profiles and all this sort of stuff until you start talking about things like Microsoft RDP and other products like Citrix. So especially when you have a user that connects to multiple Windows instances, if they're logging in and their settings are resetting all the time, or they've got to set up their Outlook profile again, or they lose their internet favorites, or whatever it might be, anytime the user has to interact with the Windows environment, you want those settings to be the same, to be managed, to be delivered for them as quickly as possible, and so that when they log into a Windows environment, it's quick. It's not slow, it's not waiting to load hundreds of gigs of information from their profile. And ultimately, what we're aiming for in these sort of scenarios is that the user settings are consistent regardless of the environment or the Windows operating system or the Windows desktop that they're logging into. So in that scenario, that's exactly what we're trying to achieve here with something like AWS AppStream. But particularly when you're thinking of the AppStream images as Dory out of the Finding Nemo series. So these images are non-persistent. They're forgetful fish. Every time a user logs in, if there's a setting that isn't applied for the user or managed for the user, then the user's going to have to apply that setting again, whether it's setting up Outlook or whether it's a favorite in Internet Explorer or something like that. If these settings aren't saved for the users or they're not provided, they will be lost. So in those instances, though, you need to make sure that when you're configuring your image and when you're configuring your applications, you're building for Dory. And basically, you're providing this information for the user so that the user doesn't have to do it, or so that the user doesn't lose it. But also in other instances, locking settings down so that the user can't configure stuff that it shouldn't be changing or don't need to. And that ultimately means that you're providing all the settings for all the applications that the users might need and hiding all of the others, so that really what you would hope to get to is that you could eliminate the need for Windows profiles entirely. Now, there may be instances and applications that just won't work with that and they won't cope, and that's fine. You can cater for those, you can spin up your own images, you can spin up your own management environments and software to do that, to deal with those sort of scenarios. But I think personally, and based on experience, that if you can aim for a profile-less environment where the user is logging in and all of their settings are being provided for them, they never need to save any sort of information into a profile because all that information already exists. So I think that's a really good aim to try and get to that scenario. Now, it means a lot of hard work, a lot of scripting, a lot of environment management, a lot of application management, but it's not impossible. And certainly in the days of coding and infrastructure as code and Ansible and all that sort of stuff, I think it's absolutely achievable. Like I said before, profiles are absolutely required, save the bare minimum, whether it's just some registry keys and some files. And there's products that are out there that allow you to do that. You could look at products like Liquidware Labs, AppSense, which is actually now Avanti. You could look at Microsoft's solution, which is UEV. And there's lots of other products out there that help you manage your environment and your profiles. You could have configurations external to the applications and stuff like that, and they could be applied at the runtime. So for example, let's say I have a product called SAP. It's an application that's installed in my image, but it needs a configurational file that changes frequently. So don't put the ini file in the image, because you're going to have to update your image weekly or monthly or however often just to change that file. Set it in such a way that your ini file lives outside of the image on a share or in somebody's profile or somewhere external to the image, so that you can manipulate the changes to that profile or that image, and or to that ini file, for example. And when a user logs in to try and use that application, it imports that ini file first, then goes and loads, let's call it SAP. So in that way, you don't actually have to update the image. The information is applied to the user, and you dynamically get to update that file as often as you want without having to go in and change your image as frequently. Get the latest versions, of applications from the web, particularly in scenarios where environment version control isn't that important. So you could just instantly go and connect and get the latest version of Office 365 or Adobe PDF, download them straight from the internet, script the installation of that, and you're always up to date. Use application virtualization or app containerization where possible. Now, we're talking here for things like separation of applications, separation and virtualization of middleware and things like Java, so that you could have multiple versions of Java on the image if you needed to have that, and so that they're isolated and they're hidden away from the users, but only called when either the application or the user's environment needs for that sort of middleware to be loaded. And you can use products that are out there at the moment. There's FS Logic, Microsoft AppV, there's Turbo.net. There's lots of products out there that you can use to virtualize and containerize your applications, and also in some instances deliver the apps to the image outside of the saved image. So you could actually be delivering apps dynamically to an image, and just having the images as basically CPU and RAM, and it runs these new applications dynamically. So in the instances of, let's say we're using Turbo.net, Turbo.net could connect to its own cluster, its own cloud environment, etc. It could download the latest version of Java, and off it goes. As soon as the new version of Java is available, it'll cache and download that to the local machine. The user opens a product, whatever it might be, that requires Java, and it's available and it's launching and it's downloading the latest version of Java without actually installing Java into your image, without changing your image in any way, without impacting other users on that environment. Especially if it's a multi-user environment, you want to protect these users and isolate them as much as you can. Overall, there's a lot there and a lot to cover, so I hope it's kind of a bit of an idea and paints a bit of a picture on how we can go about managing some of these things. So we're now going to talk through the sort of the scripted build example, and this is ultimately what we're going to do next in our demonstration, but we just wanted to talk about what the build script will do. So we're going to walk through the build script example now. It prepares the image and it connects to AWS S3. Now, I'm using a read-only user. You can use, obviously, a read-only user, and it's up to you as to whether you use or leave the credentials in the file or you provide them at runtime. Totally up to you, so long as the file is protected or the permissions to the IAM user are protected as well. You could lock that down and make sure that the user can only ever read from this particular bucket. I personally think never putting your access keys and those sort of things in a file is actually a better practice, and you just provide them at runtime, and the script allows for that. It downloads a complete directory from S3 with all of the required installation files. So not only have we got the script in there, but we can provide things like SQLite, which now allows you to manipulate the image assistant database. It will download Office 365. It can download Adobe PDF. You could save copies of those into this build document and call them directly. Things like that. It has options for multiple image selections, so if you're building image 1 today, and that could be your HR image, then off it goes and it will just only install the HR stuff. And of course, if you were installing a finance part of the image, and it was on a different image, of course, then the script would go and only install the finance requirements and settings and those sort of things. We have a section for application installations. Now there is a generic section for application installs, like Adobe PDF. Let's assume that that's a generic app that we need to install across all our images, and on an individual on an individual image basis. So again, sort of the HR or the finance analogy, we can separate those installations and only install things for HR or only install things for the finance users, stuff like that. It creates a login script for current user settings. So whoever the user is when they log into the image, whether it's a domain join or whether it's just purely the local user for the local streamed user, there's a login script that will run, and that does a lot of important things. First and foremost, it kills off Internet Explorer enhanced security. That continues to come back and is actually a known issue with Windows Server 2012, particularly on AWS AppStream. It took me a while to get rid of it and stop it coming up, and particularly in instances where you're trying to access sites that are secure and it would prompt 100 times. So it is important to have that login script there. And there's lots of other things you can add to that to have just-in-time settings applied for the users as they log in, or manipulating the HKey current user. It imports previously backed up GPO settings, and so anything you've applied to the machine or your image using GPEdit, you can export those settings as one big file, and then you can import all of those settings onto the machine. Now, that's not really relevant when you've got an image that's built or joined to the domain. It's really relevant though, and really useful when you've got a machine or an image that's standalone. So the settings are there, and it shows you how to do that if and when you need to choose it or when you need to use it. It injects applications into the AppStream Image Assistant, and that's basically it now in a nutshell. So it's in the next demo part, which we'll connect to in the next video, we'll walk you through how we run the script, how we connect to it, what it's doing, what it's manipulating, what it's changing, and then finally saving that image as a new image, and even some scripts and stuff that we can do using the AWS CLI to start automating the creation of our image builder, the creation of our stack, and the creation of our fleets, that sort of stuff. Really, to really get to a point where we're scripting all of this sort of stuff. So, and there we go. Sorry, you can see imports previously backed up GPO settings can be ignored if the image is joined to the domain. So it really is only useful for a standalone sort of image, but we'll talk through that as we do it as well. So in the next video, then, we're going to go through our demo. We're going to start the AppStream image build script, and I'm going to show you what that looks like, and we're going to deploy a new image builder as well, so we can walk through all those steps. So guys, thanks very much for joining for this video, and we'll see you in the next one. Bye now.